Welcome to the afternoon session of Tech Days Online 2012. This is the Windows Azure session for the IT Pro. And my name's Steve Plank. Everybody actually calls me Planky, and you should do too. So we've got an agenda this afternoon, which consists of, if my slides will advance, it's basically only 5 topics. We've got the public cloud landscape. So I want to put some clarity around what the public cloud is and how it's segmented. There are different aspects of it, and I want to sort of put some clarity around that. We then got a section on Windows Azure Virtual Machines, which was introduced in Windows Azure on June the 6th with an announcement of our IaaS features. I'll tell you what that means in a minute. Allied with that, we've got things called virtual networks. We'll talk about that. Then once we understand what virtual machines are and virtual networks, that leads us nicely into Windows Azure's Active Directory features. 2 ways of doing it. One is to put domain controllers in the cloud and deploy a traditional Windows Azure Active Directory. The other is to consume a service which is currently in preview called Windows Azure Active Directory. The 2 things are not the same, they're different. I'll put clarity around that for you as well. And then I've got a SharePoint system deployed. I just want to talk around, how you would do something like that. If what you wanted to use the cloud for was to put a traditional infrastructure into the cloud, a file server, a SharePoint server, a web server. Print server's not such a good idea, but all those other things, pretty good idea to do that kind of thing. So let's have a look at the cloud computing landscape. When you look at this is a picture which shows what you have in your on-premises environment. So this is what you have in your own data center. And if you look, you're responsible as the operator of that system for everything from networking, storage, servers, and virtualization, right up through the stack until you get to the operating system. So there you're getting into software. You're getting into being responsible for things like patches, service packs. If a security vulnerability for your operating system is identified and a patch is released, it's up to you to patch that. Middleware runtime, so you've got platforms like, for example, .NET, Java, PHP. These are all platforms on which you could run. Middleware platforms like, for instance, Apache or IIS. And then eventually you get up to the place where the business value comes in, which is the data and the applications. If you write your own applications, then you're responsible for patching those. If you've got problems with runtimes or middleware, then when the vendors of those middleware or runtime platforms issue patches, you deal with that. So you deal with everything from crawling around underneath the floorboards for the cables, all the way up through to looking after your own application, and you're responsible for the entirety of that. Some people would say you're responsible, and other people would say you have control. Now, depending on whether you're the sort of person that sees a glass as half empty or half full, you'd view those 2 things as differently. What I like is the idea of getting rid of some of the responsibility. And that's what the IaaS public cloud does, the infrastructure as a service. What it's saying is, we will give you an infrastructure on which you can run your infrastructure. So the operator of the cloud, in this case Microsoft, operates the virtualization, the servers, the storage, and the networking. But you still have responsibility for looking after the operating system. So for example, you might build an operating system in your own virtualization environment, and you might, for example, copy that to the Windows Azure cloud as a VHD, and it would sit on top of those gray boxes that you can see there, the virtualization, the storage, the servers, the storage, and the networking. But you're responsible for it. So if there's something goes wrong with it, you've got to fix it. If it's misconfigured, you've got to fix it. If there's a patch that comes out, you've got to install it. If there's a service pack, you've got to install it, and so on. All the way up in exactly the same way as we talked about before, up to the application and the data. Now, the great thing about IaaS platforms is that you can typically pick up a VHD from your on-premises environment, move it across, and drop it into the IaaS environment. So that means that for the migration of applications, IaaS is a really good solution. Now, if we compare that to PaaS, you can see that almost all of your responsibility, or depending on the sort of person you are, all of your control, but all of your control or your responsibility is taken away from you. And what you basically do is, as an application developer, you write your application, you package it up, you get your data, you send both of those things to the cloud operator, Microsoft, and you say, can you run that for me? And here's an architecture I'd like you to run it on. You might define that you want a web front end, a middle tier, a database at the back end, and so on. The great thing about PaaS, of course, is that you can see a lot of the responsibility has been taken away from you, and so all of that service management stuff, you know, when a virtual machine in your estate of whatever that application is, when that virtual machine dies, the PaaS environment says, well, we'll recognize that and we'll reboot the machine and we'll bring it back into the configuration and we'll do all the stuff that we need to do. So for example, let's imagine that you run your own virtualization environment and you, let's just imagine that you have a machine which crashes. So you hit the reboot button, it comes back up again, and then 2 minutes later it crashes. So you hit the reboot button, it comes back up again, and 2 minutes later it crashes, and that just keeps happening. What you would probably do in a first step is decide to deploy that to a different host. Now that would be your management task would be to decide to make that decision and to move it to a different host. With Windows Azure, in a PaaS environment, the Windows Azure platform does that for you. It just monitors all the stuff that's going on, sees that this machine has rebooted several times and says, that workload is obviously no good on that host, and it will just move it to a different host for you. And it will do all the stuff that it needs to do, all the networking, all the connecting up to the load balancer, all of that kind of stuff will be automated. And so in terms of service management, you have almost nothing to do. You do still have some tasks to do, for example, if you want to scale out or scale back, but you can even write that into your code as well if you want to. So the advantage of a PaaS environment is that you don't do infrastructure and service management. The disadvantage is that if you want to deploy an application to the PaaS environment, what you basically have to do is you have to start from scratch and write your application to run in this specific PaaS environment using the APIs that are supplied by that environment. If you want to, so that's the advantage and the disadvantage. The advantage of an IaaS environment is that you can migrate an application, an existing application, very quickly. As long as that application doesn't rely on big bits of infrastructure, like for example, if it relies heavily on Active Directory and you take the application out of your corporate network, move it outside of the firewall and into a Microsoft data center in another country somewhere, clearly that's going to have a problem. But if it's a standalone application, you just lift it, move it across and drop it in, it's pretty much going to work. So the advantage of the IaaS environment is really, really fast to migrate things. The disadvantage is that you have that increased responsibility. You still have to look after the environment. Now, if you contrast those two things with the SaaS environment, and SaaS is software as a service, and that's where the entire application is under the control of the vendor. So, for example, Exchange Online, part of Office 365, Link Online, SharePoint Online. These are all services that are offered by Microsoft, and the entirety of the application, the infrastructure, the hardware that it runs on, everything is run in the Microsoft cloud, and you have no control over that whatsoever. What a lot of people do, a lot of vendors do, is they use either IaaS or PaaS environments, and from that they build a SaaS solution and they sell a SaaS solution to their customers. And typically, not always, but typically SaaS solutions are charged per user per month. But you could, I talked to a company that does logistics and they charge per delivery, for example. So there are lots of charging models. But this is the landscape that we find in the public cloud today. So you're going to find that you're either an IaaS, a PaaS, or a SaaS vendor. In the case of Microsoft, we're all three of them. Okay, so the bit that we're going to concentrate on now is the IaaS environment, and that really means virtual machines and virtual networks. And I will talk a little bit about the PaaS environment before we get into that, just to give you a sort of a feel for what you can do with it. When you look at the aims of these things, you can say that IaaS is really aimed at the IT pro, and PaaS is really aimed at the developer, because the developer is going to write their code, package it all up, send it away to the cloud and say, can you run that for me? Whereas the IT pro is going to be very interested and very, oh, excuse me, my phone is ringing. I'm just going to switch it off. I'll actually switch the phone off. With the IT Pro, because the IT Pro will possibly move an application, move a VHD or install a VHD from within Windows Azure itself, and they're responsible for that ongoing management of that infrastructure. That's a service management job, and that is really the job of the IT Pro. So you can see why it is that they tend to be aimed, one for the developer, one for the IT Pro. Or should I say, one for the developer, one for the IT Pro. Okay, so when we look at platform as a service then, let's just have a look at what that actually means. I'm just going to demo deploying a large service. I'm sure that you all have this kind of an environment. This is a video just showing a 3-tier architecture with the internet connected to a firewall. The firewall is connected to a load balancer. The load balancer is connected to a couple of instances, a couple of virtual machines which do the web tier. They talk in their turn to a middle tier, which has got the business logic in it. That talks to a database cluster. And then it's not very long before you start needing to do things like, backup, monitoring, reporting, all those sorts of things. And so the application tends to grow and grow and grow and get quite big. So here we've got a 3-tier architecture, but when you look at how much hardware and how much infrastructure is involved in this, it's quite considerable. So what we can do in the passive environment is we can take that description, if you like, that's a description of an architecture on which an application can run. The application still has to be written. Somebody has to still sit down and write code. But we can deploy that application onto the various tiers, the database tier, the middle tier, the web tier. We can do firewall configuration, load balancer configuration. We can have code running on policy, backup, monitoring, those sorts of parts of the application. We can describe all of that in XML, and that's called a service model when we do that. And then we can take that service model, and we can take our application code, the thing which runs on the web tier, the middle tier, and all the actual executable procedural code. We can package all of that up together into one package, and we can send it off to the vendor, Microsoft, and say, can you run that for me? So let's have a look at how we do that. So I'm going to go to a demo now. So if I go to the Windows Azure portal, this is the Windows Azure portal. I've got some cloud services in here, and I'm going to create a cloud service. So I say new cloud service, new cloud service. I'm going to do a custom create. I was sure I turned my phone off just a second ago. Right, so I need to give my cloud service a URL, and it's always something.cloudapp.net. There are ways to get more elegant names than that, like abc.com, def.com, but I'm just going to stick with the standard offering at the moment. So let's call this TechDays 2012 UK, or TechDays UK. TechDays UK, you can see it's here, it's checking techdaysuk.cloudapp.net. I can put this into a particular data center, and you can see I've got a number of data centers here. East US, West US, South Central US, North Europe, Central US, East Asia, Southeast Asia, and West Europe. I'm going to go to North Europe. That's in Dublin. I'm going to use a specific subscription that I've got, and I'm going to deploy a cloud service package right now. Okay, so I'll give it a name, TechDays UK. And now I'm going to get hold of the package which contains my code, and that code has already been written. So let's go to conferences, Black Marble. Okay, so there's the CSPKG. That file contains my executable code. The next thing I'm going to do is get that configuration, the file which represents that whiteboard diagram that I had. Now I'm just going to let you have a look at that file before I go into it, just so you can see what it looks like. Conferences. Okay, so it's this file here, CSCFG, Service Configuration Cloud.cscfg. Okay, and you can see here it says things like, I've got a role. Let me just, where are we? Plus. I've just done an edit on that. I'm going to have to make sure I don't save that, aren't I? I was trying to zoom in. You can see here I've got a role, that should say role, which is the web front end. And it's got an instance count. This is the number of virtual machines which are in the web front end, and that's 3 of them. And I've got some configuration settings here. We don't really need to worry about that, but it means I've got diagnostics, and I'm going to use development storage and so on. Let's go back. Why is that not moving? Let me just minimize this magnifier. Right. I've got another role here which is called CRM processing, and that's got 2 instances, so there's 2 VMs in that. I've got one here called CRM reporting, that's got 2 instances, that's 2 VMs. I've got app reporting, that's got 1 instance. So you can see here what I've got is a kind of a basic description of the different roles in my application and how many VMs are in each of those. Okay, let's get out of this, back up to here. for some reason, it is working. Right, now let's have a look at the next file. I'm not going to make any changes to that. There's this one called service definition. And you can see here it says, for the web role, which is called web front end, use a VM size of extra small. An extra small VM size is a VM of 768 megabytes of RAM and a single core processor. Not a very powerful machine. But in order for me to do this demo, I'm going to deploy quite a few of these things. And I've got various endpoints here. So you can see here, for example, I've got an internal endpoint that's used inside the data center. It's called Web Out CRM Load Balanced 1. It runs the TCP protocol, and it's running on port 1049. So what I've actually got here then is, I've got the sizes. I've got an extra small instance here for the monitoring role. I've got the sizes, and I've got the ports which are used for communication between all the different components of this application. So if I go back to my demo, back here, and let's get that file, the cloud service configuration file. And I'm going to deploy this to a production environment. I could go to a staging environment, but I'm going to go straight to production. It says deploy even if one or more roles contains a single instance. There's a reason for doing that. And then start the deployment. So let's click go. OK, so you can see here it says TechDays UK. That is currently creating that deployment. And it will be running at techdaysuk.cloudapp.net. That's the URL it will be at when it's deployed. In fact, I've said that this consists of a lot of code. It's not really true. What it consists of is a single C# application, which is a web page with a picture on it of a CRM application. So it kind of looks as though it's really rich. I want you to imagine that the application itself has been written by a team of developers and is really complicated. Actually, it's a very, very simple application. But whether the application is complicated or simple makes no difference to the platform. The only difference is the amount of time it takes to copy the number of bits that comprise that application onto the individual virtual machine. So a big application will take longer to deploy than this one. This one will probably take, I reckon, about 8 minutes. So we're going to come back and check this application in a few minutes' time and see how it's doing. So the time is now 16 minutes past 1. We'll see how we're doing in a few minutes' time. OK, let's keep going. So let's now start to talk about virtual machines. So what I've just shown you, the demo I've just shown you, is how as an IT pro you might take somebody else's code, somebody else's configuration, and how you might deploy them. I haven't shown how you'd manage them, but I've shown how you might deploy them. Now let's get into stuff which is much more to do with the IT pro themselves, and that's virtual machines. So we have this idea of cloud-first provisioning, and what that means is you have 3 ways of deploying something. There's a REST API, there's scripting, and that what we would use in the Windows environment is PowerShell. And what actually happens is PowerShell talks below to the REST API. Or you can use the management portal, and that's what I'll be showing you in a demo, how to use the management portal to create a virtual machine. When you do this, you have to select an image that you want to deploy, and you also have to select its size. So you can see here we've got either Windows Server 2008 R2 or Server 2012, or various flavors of Linux. That will come up in a few moments. And different sizes of virtual machine. Everything from extra small, which I told you already is a single core with 768 megs of RAM, up to an extra large machine. And I'll show you what those are in a few moments. And so what you get, basically, is a disk. And that disk will be your VHD, and that will be deployed onto a rack. And that rack will be running a version. It's not going to run Hyper-V, but it will be running what's called the Windows Azure Hypervisor. A hypervisor which is heavily based on Hyper-V, but is not, in fact, Hyper-V, because it's had to be modified to run in this new environment. But it does mean that you can actually copy your own VHDs from your own environment, move them into Windows Azure, and they will work. So I said virtual machine sizes. You can see the sizes here. So an extra small shared CPU core with 768 megs of RAM. And then we have a small, which is a single dedicated core and 1.75 gigs of dedicated RAM. And from that point on, it doubles all the way up to extra large. So we go from single core to 2, 4, and 8 cores. And we go from 1.75 gigs to 3.5 gigs, to 7 gigs, to 14 gigs. One of the things I think you should really notice is the bandwidth, the available bandwidth that you get for a connection from that virtual machine to the internet. Notice with an extra small instance is great for doing what I'm doing here, like demos. It's great for teaching yourself something. It's great for something which really requires very, very low bandwidth, something which might be not connected to the internet, for example, something that's processing something that you've already collected. And we have the idea of data disks as well. So we can have, this is the maximum number of data disks that we can have on each of these instance sizes. I'll tell you what a data disk is in a few moments, but if you just think of it as a place you store your data, then you wouldn't go far wrong with that. Okay, so you can either bring your own server and your own VHD. So what you basically do is you copy the VHD across. So this is an example where we've got an on-premises virtual server, we've got a file called myapp.vhd, and we upload the VHD. One of the features of VHDs that are running in the Windows Azure cloud is that they must be fixed disks. Now the tool you use to do this is a command line tool. It's called CS Upload, and that can do that conversion from a dynamic disk to a fixed disk for you during the upload process. And what will happen is your disk will go into a type of storage called blob storage. Binary large object. If you're used to that kind of terminology in databases, it's the same here. And what we say is it's really unstructured data, and you'll end up with a file called myapp.vhd inside a blob container. And once you've got it in blob storage, then you can create a disk or an image. So you can create a disk like a data disk, or you could create an image like an operating system image. And then you'll provision that, and it will end up being provisioned into a rack in the data center, onto a host, and it will be connected up to the internet. You can also create an image in the cloud itself, and the way you do that is you have your blob storage. You use the portal, and you say, I'd like to create a base VHD. It's not actually called base.vhd. You just give it whatever name you want to call it. If you call your machine machine1, it'll be machine1.vhd. You then boot the virtual machine. And from that point on, you could just use it. But what you probably want to do is customize it. So I'm sure that what you would do as soon as you've booted it, I'm sure you'll do things like install applications. You might install IIS. You might do configuration on it. You know, the things that you install on this machine to make it different will differentiate it from all the other machines that exist in the world. But then one of the other things you might want to do is you might want to be deploying and undeploying this machine frequently. So one of the things you might want to do is generalize it, sysprep it, so that whenever you boot the system up, it's got all the binaries on it, for example, that you might want to do. An example might be that you boot an operating system, you put all the SharePoint binaries onto it, you sysprep it, and you store it away. And that process of storing that image away and being able to recall it in the portal is called capturing the image. So once you've got a captured image, then you can deploy a version of that image whenever you want to. You store that in blob storage. Okay, and from that you could, for example, if you use the SharePoint analogy, you could create a SharePoint farm with 3 SharePoint servers in it. Each one would be called, SharePoint VM1, SharePoint VM2, SharePoint VM3. They'd all be separate instances, but they'd all be based on that generalized sysprepped image that you created in the first instance. Okay, now if you've got on-premises Hyper-V environment and you've got your own Windows Azure cloud environment, then one of the things you can do is you can copy things one way, I've already said that, but you can copy them the other way as well. So you can, if you want to, create an image in the cloud and then copy it down into your own Windows Azure, your own Hyper-V environment and run it on your Hyper-V host. Now, when we get into disks, there are 2 types of disks. There are operating system disks, and no surprise, they contain operating systems. And there are data disks. Now, the difference between an operating system disk and a data disk is that an operating system disk will, by default, go through a cache before a write occurs. Now, and a read, in fact. So if you imagine this is your operating system image, let's imagine this is some hardware, and you've got a USB cable. And let's imagine that you plug the USB cable into the hardware. So that's the process of connecting a disk. And then that USB cable, let's imagine that there's a little box that you put in between it and the actual hardware, and that's the cache. So you put this into a cache, you've got another USB cable that goes into the cache there, and then it goes into the hard drive. So if you imagine that complete little section of hardware there, the hard drive, the cable, the cache, the cable, and then the hardware, Now let's make an analogy between that and Windows Azure. So we've got our operating system image, that's the hardware. We've got our cache, that's an operating system disk cache. And we've got the actual operating system disk. So those things get unplugged, and what we can say is that whenever we do a write, it goes into the cache first of all, and then sometime later, the cache will empty itself into the disk. We don't know how often that is. It might be every few milliseconds, it might be every few microseconds, it might be every few seconds. I'm sure that the people who run the Azure data center play around with these parameters continuously, and whatever number it is, 1 week will be different the next week. But it does mean that data that the operating system disk, the operating system believes has been fully committed to the disk might not have been. It might still be in the cache, and that can be an instance of a case. Not such a big problem with an operating system disk, because what happens is, if you've made an operating system change, for example, you made a write and the system fell over at that point. When it comes back up again, it does a disk consistency check, and so you're fairly protected in that kind of an environment. But with data disks, it's a bit different, and so they tend to not have a cache in the first place. And this is going to become very important when I start talking about Windows Azure's features of being able to run Active Directory. Because, in fact, let's wait till we get to that point to talk about it. So, we have the idea of persistent disks that will maintain their data across reboots exactly as you'd expect. So the C drive is an operating system disk. D is a non-persistent cache disk, so that's where your page file will be. And you could create a temp directory on there, and there's no guarantee that it will persist across a reboot. And then you have data disks, everything from drive F. It says E there, but the very first time you ever connect a drive up, it'll be drive F all the way through. And as you saw in an extra large instance, you can have up to 16 drives. Each drive is based on a blob. A blob can be 1 terabyte, so it means you can have a maximum of 16 1 terabyte drives. You could stripe across all 16 of those and have one large 16 terabyte striped drive. Does that mean that your data is at risk? Because if you lost a disk, if you lost one disk in a 16 disk stripe set, that's kind of risky. Well, let's have a look at what happens. The persistent disks we're talking about actually are copied 3 times within a data center. So your data is stored on 3 what are called storage nodes 3 times. And to add to the safety, they are also replicated to another data center. So for example, Dublin's partner data center is always Amsterdam. Amsterdam's partner data center is always Dublin. We've got Southeast Asia and East Asia. They're a pairing. We've got West and East US, and we've got North and South US. Each of those is a pairing. You can actually switch off that data replication if you want to, because you have to pay for the storage. You pay per gigabyte. Even though, 1 gigabyte, take the green box here, 1 gigabyte is 15 cents per gigabyte per month to store data. So 1 gigabyte, even though it takes 3 gigabytes of storage space, you pay for the 1 gigabyte. But if you go to another data center, then that's another gigabyte, so you pay extra money for that. Okay, so you might want to switch that off. But what it does mean is that if you lose some data, so if your virtual machine fails, well, it's not such a big deal because you've got 3 copies of the data, and so there'll always be another copy in the data center somewhere, unless the entire data center gets taken out. And if that happens, then obviously, obviously you could go to a disaster recovery site. You could go to the alternative data center, and you could boot from that data center. Okay, now virtual machine names, they all will have DNS used internally inside the network, and if you want to connect them to the outside world, they will have an external DNS name. Now Windows Azure provides its own DNS, and that's what gives you the .cloudapp.net namespace for the outside world. You can use CNAME records to get your own domain names mapped onto those names. And it has its own DNS server for the internal network. So if you have two machines, they also have DNS names, and they find each other through DNS inside the internal network. You can actually bring your own DNS server if you want to, and that's what we do with virtual networks, and in fact I'll show you that a little bit later on. Now, when we have 2 virtual machines, let's just say we've got 2 web servers, 2 virtual machines running IIS, we can connect them both up to the same load balancer, and we can load balance across them. One of the things that we might want to do, though, is we might want to RDP into these machines, use the remote desktop protocol to get connection. Now the problem that we have is whenever we create a Windows Azure service with more than one, well, if it's got one machine or 20 machines in it, it doesn't matter. Whenever we create a Windows Azure service, we only have one external IP address connected to the internet. So how can we RDP into, let's just say, 2 machines? And you can see how it's done here. Let's just imagine that we've got a request coming in from the internet, it hits the load balancer, it hits port 5586. Well, then what happens is the load balancer maps port 5586 to a specific IP address, VM1's IP address, and port 3389. If we come in on port 5587, then the load balancer maps 5587. It probably won't be these exact numbers, it's numbers in this area, but it will map 5587 onto a specific IP address, VM2's IP address, and port 3389. So that's how we can distinguish between virtual machines by just doing some port mapping, and that's exactly what happens in the environment. Do you have to set it up? No. All you have to do is you have to connect your virtual machine up to the load balancer, and it will take care of all of that for you automatically. Okay, we can also have load balance sets, so we could have 3 copies of IIS, in this case, three IIS servers, and port 80 connected up, and that would mean that when the request comes in on port 80, it gets routed to VM1 in the first instance, and then the next request goes to VM2, VM3. 1, 2, 3, 1, 2, 3, 1, 2, 3. If I add another machine into it, it'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. If I take 2 machines away, it'll go 1, 2, 1, 2, 1, 2. So you can see that it's a very neat way of providing a load-balanced architecture. You still have to write your application to take account of the fact that any one of these machines could get the request, but modern developers are used to doing this because it's a modern way of writing applications. It's one of the reasons why older applications tend to be more difficult to port in the PaaS environment because of all that sort of setup that has to be done. Okay, I said earlier that we created a virtual machine. Let's have a quick look and see if it's deployed yet. Okay, so I created a service called TechDays UK. It says that it's running, so if I go to the hyperlink, it's going to techdays.uk.cloudapp.net, and there's my application now running. So anybody out there now who's watching could go to techdays.uk.cloudapp.net and you'll see this application running. If there are hundreds of you and you all do it and it's deployed on a small instance, it's probably going to fall, it's probably not going to cope with the load, but you could all have a try at that. Let me just go back to the Cloud Services homepage and we'll drill into this and have a little look. So what we see in this cloud service, and remember this is a PaaS environment, this is not virtual machines, this is a PaaS environment. It's all running on virtual machines, but we don't really see them as virtual machines. We've got a dashboard here. It shows us that actually not very much has been going on with this. It's actually running 10 cores, so it's got 10 virtual machines deployed. I think that's because I deployed them all with single core servers. I can monitor it. Any second? Now that's taking a little while. Let me come back to that in a minute. I'll just look at the instances, and you can see these are all of the different instances. So I've got 1, 2, 3 web front ends, 1, 2, 3, 4 CRM processing modules, app reporting policy, and a monitoring instance as well. Okay, so those are my virtual machines. They're all extra small instances, keep the cost down for Microsoft, because my cost center gets charged for this. And they're all running. And I didn't have to do anything. All I did was I wrote some really simple code, but it could have been complicated code. I created my service model, that XML file. I sent them to the cloud, and poof, it's gone away and done it for me. So you can see why this is very interesting for a developer. Now, you can see I've also lost some control, and that's where the idea of an IaaS environment comes in, because I gain some of that control back again.